Hello everyone, welcome back to my YouTube channel. I'm a student studying in Sri Venkateswara College of Engineering, Bengaluru from the Department of Basic Science. So today I'll be presenting a topic called corrosion and its types from the subject Applied Chemistry for CSE stream. So today's topic is corrosion and its types. So let's begin the topic with a little introduction. So corrosion is basically defined as natural tendency of metal which undergoes destruction by dissolution or by chemical or electrochemical reactions, which can in fact lead to structural damage, loss of functionality, and ultimately failure of the material. Understanding the types of corrosion is very much essential for prevention and mitigation strategies. So corrosion is basically similar to rusting, in which the metal undergoes destruction by chemical or electrochemical reactions, which leads to structural damage and loss of functionality of the metal and failure of the material. So understanding which type of corrosion has occurred helps us prevent the corrosion and helps in mitigation strategies. So next we have types of corrosion. Under the types of corrosion, the first one is uniform corrosion. So uniform corrosion, the name itself tells us the corrosion happens evenly over the surface of the material, resulting in thinning of the material, which is also influenced by the factors such as temperature, humidity, and the presence of corrosive agents. So the common examples which come under uniform corrosion are rusting of iron and tarnishing of silver. Next we have galvanic corrosion. Galvanic corrosion happens when two dissimilar metals are in contact in the presence of an electrolyte, creating a corrosion cell. When two different metals are in contact in presence of an electrolyte, it creates a corrosion cell, and this is called galvanic corrosion. And galvanic corrosion happens with two dissimilar metals. And there's one more thing in galvanic corrosion: the more active metal acts as anode and corrodes, while the less active metal acts as cathode and which is protected. So basically in galvanic corrosion, the anode gets corroded and cathode gets protected. If one gets corroded, the other one gets protected, which means the more active metal and the less active metal. Under galvanic corrosion, examples under galvanic corrosion, we have plumbing systems and marine environments. Next we have service corrosion. So this type of corrosion occurs in confined spaces or gaps between two surfaces where oxygen levels are lower and corrosive agents can accumulate. This type of corrosion occurs between the gaps of two surfaces where oxygen levels are a bit lower and corrosive agents can get accumulated in between the spaces, and it causes corrosion. This can lead to localized pitting and accelerated degradation of the material. It is similar to pitting, but it's not exactly pitting, and it can also lead to degradation of the material. So this type of corrosion is commonly found in fasteners, joints, and steams of structures between the small gaps and edges. Next we have pitting corrosion. Pitting corrosion is characterized by small localized holes or pits on the surface of the material. Basically the holes between the surface is what is called pitting corrosion. Because of the holes, the corrosion gets created, and that's what is called pitting corrosion. It can be challenging to detect early on, but can cause significant damage over time. This type of corrosion commonly occurs in stainless steels and aluminum alloys. Next we have intergranular corrosion. So basically in this type of corrosion, it occurs along the grain boundaries of the material, weakening the structure. Intergranular corrosion, it occurs inside the boundaries, grain boundaries of a material, which leads to weakening of the structure, and it is often caused by sensitization of material due to heat exposure during welding or other processes. So this type of intergranular corrosion is commonly seen in stainless steels and other alloys with specific metallurgical properties. Next we have stress corrosion cracking. So under this type of corrosion, it is combined effect of tensile and corrosion leading to crack and initiation and propagation. It can occur in materials exposed to corrosive environments under mechanical stress. Most commonly it is seen in pipelines, aircraft components and nuclear reactors. Next we have erosion corrosion. So erosion corrosion is a type of accelerated corrosion caused by combined effect of corrosion and abrasive wear. So this type of corrosion occurs in high velocity fluid flow environments where particles or impurities in the fluid abrade the material. This type of corrosion is commonly found in piping systems, pumps and turbine blades. So the next one is microbial corrosion. It's also called MIC. So this type of corrosion is known as it's also known as biocorrosion, hence because it includes bacterial, so it's called also named as biocorrosion. So this the name itself suggests that this corrosion is caused by the activity of microorganisms such as bacteria, fungi and algae. So these microorganisms can produce corrosive byproducts which degrade the material. So basically this type of corrosion is found in environments, marine environments, oil and gas, pipelines and cooling systems. Next we have the factors which affect the corrosion. So environmental factors such as temperature, humidity, pH levels and the presence of corrosive agents, they all play a significant role in corrosion. So material properties, surface condition and design considerations also influence the corrosion resistance of a material. So basically factors which are affecting the corrosion, we have environmental factors such as temperature, pH, humidity, etc., which play a significant role in protecting and preventing corrosion. Next we have material properties such as the type of material, surface condition, design considerations. Also all these type of things also influence the corrosion resistance of a material. Next we have proper maintenance, coating and cathodic protection which can help prevent corrosion. Next we have corrosion prevention and control. So corrosion prevention strategies include the use of corrosion resistant materials, protective coatings, inhibitors and design modifications. Cathodic protection techniques such as sacrificial anodes and impressed cutting systems can protect the structures from corrosion. Regular inspection, monitoring and maintenance are crucial for identifying and addressing corrosion issues. And next we have corrosion testing and evaluation. So corrosion testing methods such as salt spray testing, electrochemical techniques and accelerated aging tests are used to assess the corrosion resistance of materials. Evaluation of corrosion mechanisms, failure analysis and root cause identifications are also essential for developing effective corrosion control measures. Collaboration with corrosion experts, materials scientists and engineers can help in addressing complex corrosion challenges. Next we have the future trends in corrosion control. So advancement in material science, nanotechnology and coatings are driving innovations in corrosion technology. Development of smart materials, self-healing coatings and predictive corrosion monitoring technologies are shaping the future of corrosion prevention. Emphasis on sustainable and environmentally friendly corrosion control methods is gaining importance in research and industry. So this is about the topic corrosion and its types. Hope you guys liked it. Please like the video, share it and subscribe to my YouTube channel. Thank you.